In the space of science and huge, favored bits of knowledge, the subject of what existed early on to the gigantic effect has sparked discussions and captivated thinkers for a long time. This profound question doesn't just test how we interpret the universe, it challenges the very limits of human knowledge. Imagine standing at the edge of existence, examining the vast unknown, and wondering what lay there before our universe was conceived. The event of the Big Bang marked the beginning of what we know about the past, present, and future. But was there a moment before this? Could there have been a state of nothingness, a calm before the storm? And if so, was it truly empty? Or perhaps something even more mysterious existed before time itself? As we dive deeper into this question, science takes us on a journey beyond the universe's early phase, into concepts that challenge our understanding. Physicist Brian Cox, recognized for his dedication to the wonders of the cosmos, suggests that something astonishing may have existed before the Big Bang. He urges us to rethink our understanding of reality and existence. In this exploration, we'll break down the science, the theories, and the incredible secrets that might explain what existed before everything. We'll examine ideas such as eternal inflation, quantum fluctuations, the multiverse, and dark energy. The answers we uncover may shock you, but they could also open new perspectives on our place in the universe. Prepare to delve into a world beyond imagination and science, where darkness still weaves through the shadows, leaving researchers both amazed and unsettled. Let's analyze what might have existed before the Big Bang and why these theories challenge everything we thought we knew. To understand what could have come before the Big Bang, we first need to examine what the Big Bang actually was. Researchers describe it as the moment when the universe became extremely hot and dense, expanding rapidly to trigger the formation of all matter, energy, and the fundamental forces. When we observe the night sky, we see evidence of this fiery beginning, galaxies spreading outward from an initial point. But what caused this to happen? Was there a time before this dense, hot origin? According to the theory of cosmic inflation, there was. Before the Big Bang, the universe existed in a state that was cold, empty, and seemingly void, like an expansive vacuum. However, this vacuum wasn't truly empty. It contained an enormous amount of energy that fueled the rapid expansion of space itself. This expansion, called inflation, occurred so rapidly that it essentially set the stage for everything that followed. In a fraction of a second, space expanded at unimaginable rates until inflation slowed, and the energy transformed into matter, particles, and forces, giving birth to the universe we know today. But what was the nature of this energy? Why did it suddenly trigger the universe's creation, and why did it stop? Scientists believe that this limitless expansion created different regions of the universe, each undergoing its own Big Bang. Imagine a fabric stretching endlessly, with small air bubbles forming, each bubble representing a universe, including our own. This idea, known as the inflationary multiverse, suggests that an infinite number of universes may exist, each with its own version of physical laws. Our universe is just one among countless others. This vast, mind-bending concept challenges our understanding of reality and raises the question, what else is out there? The idea of nothingness before the Big Bang is hypothetical, not proven, at least based on our current understanding. Even if you removed all energy, particles, and radiation from the universe, it still wouldn't be truly empty. The universe is filled with dark matter, dark energy, quantum fields, and forces we don't fully comprehend. Even in its most empty state, the universe still contains something. If we could strip away all known forces, leaving a void, quantum mechanics suggests that new energy would still emerge. This concept baffles scientists because it implies that true nothingness may be impossible within our current understanding of space. Space itself has properties, rules, and constants that prevent it from being completely empty. Creating a region with absolutely nothing, no particles, no radiation, no energy, would still leave behind quantum fields and fundamental constants. These would continue to exist, suggesting that this nothingness still has properties. For example, there's a concept called zero-point energy, which represents the lowest possible energy state of quantum fields. Even in this state, particles can momentarily appear and disappear, creating a subtle but constant fluctuation, even in what should be an empty void. This challenges our understanding of a true vacuum and suggests that even before the Big Bang, something must have existed. One of the most fascinating theories in modern cosmology is the concept of eternal inflation. If inflation created our universe, could it have continued indefinitely? Brian Cox describes an unimaginably vast inflationary multiverse where universes are constantly forming and expanding. Imagine each Big Bang as a spark igniting a new universe, while inflation continues elsewhere, generating countless others. This process could, in theory, go on forever. This immense idea suggests a fractal-like universe, where each new universe may spawn its own Big Bang, creating an endless cycle of cosmic birth and expansion. For scientists, this theory is both exhilarating and unsettling, as it implies a multiverse with no definite beginning or end. Imagine our universe as just a tiny fragment in a vast cosmic web, continuously generating new universes. If this is true, then perhaps there is no before or after, only an eternal cycle of universes forming and evolving. Our understanding of nothingness shifts when we consider quantum field theory. According to this theory, the universe isn't just a collection of matter floating in space, rather, it's a complex network of energy fields that permeate the cosmos. These fields behave like invisible oceans, with particles acting as waves or disturbances. Even when these fields are at their lowest energy state, known as the vacuum state, they remain active. Virtual particles can appear and vanish in an instant, borrowing energy before disappearing again. The existence of virtual particles challenges the idea of a true void. Even in an empty universe where all energy, matter, and radiation are removed, quantum fields would still fluctuate, producing transient particles. This constant activity in what should be nothing suggests that the universe is never truly empty. The presence of these fields and forces fills space with residual energy, preventing absolute nothingness. This raises an intriguing question. If fields create particles, and particles create matter, could our universe have emerged from an empty space filled with quantum fluctuations? Dark energy is a mysterious force driving the accelerated expansion of the universe. But did dark energy exist before the Big Bang? Some theories suggest that dark energy today is a lingering effect of an energy field that existed before our universe formed. The properties of dark energy imply that a powerful, unknown force may have shaped the conditions leading to the Big Bang. Some scientists believe that dark energy, in a much stronger state, could have driven the inflationary phase, causing the universe to expand at an astonishing rate. If dark energy played a role before the Big Bang, it raises a profound question. Was our universe born out of a transformation in an already existing cosmic framework? Could there have been a prior state, an ancient, unknown reality that collapsed, evolved, or transitioned into what we now recognize as our universe? One possible answer lies in the idea of a cyclical universe. Some theories propose that the cosmos undergoes infinite cycles of expansion and contraction, where each Big Bang is not the beginning but rather a rebirth following the collapse of a previous universe. This concept, known as the Big Bounce, suggests that before our universe, there was another one, and before that, another, each following a continuous cycle of destruction and renewal. In this view, the universe never truly begins or ends, instead, it moves through an endless rhythm of cosmic rebirth. If true, this would imply that time itself may stretch infinitely into the past, eliminating the need for a single moment of creation. Another possibility is the existence of a parent universe, a higher dimensional reality from which our own universe emerged. According to string theory and M-theory, our universe may be just one of many three-dimensional brands, short for membranes, floating within a higher dimensional space called the bulk. In this scenario, the Big Bang might have been the result of two such brands colliding, unleashing a massive release of energy that formed our universe. If brain collisions occur repeatedly, then universes could be continually created, each with its own unique properties. This idea also connects to the notion of parallel universes, realities existing alongside ours but hidden from view. Could these other universes have existed before our own? And if so, do they still exist, shaping the cosmic landscape beyond what we can perceive? Even more intriguingly, some scientists speculate that our universe could be a simulation, a construct within a vast computational system. If this is the case, the before question takes on an entirely new dimension. Rather than a physical event preceding the Big Bang, it could have been a moment when a higher intelligence initiated the simulation, a cosmic program beginning its execution. This hypothesis, while controversial, raises philosophical implications about the nature of reality. If we are part of a simulation, what existed before it began? And is there an ultimate creator or a deeper layer of reality beyond our comprehension? No matter which theory one explores, the question of what existed before the Big Bang remains one of the most profound mysteries in science. Each new discovery, from dark energy to quantum fluctuations, pushes the boundaries of human knowledge. As we continue searching, we may one day uncover the true origins of our universe, or perhaps realize that the answer lies beyond what we can ever comprehend. For now, the universe continues to expand, carrying with it the echoes of its mysterious past. And as we peer deeper into the cosmos, we are reminded that the search for answers is as infinite as the universe itself. This possibility, we face the potential of dark energy not as a force shaping our universe but as a key that could unlock the secrets of the multiverse itself. Another hypothesis is that cyclic cosmology offers an alternative to the Big Bang as a definitive beginning. This theory suggests that the universe goes through gigantic patterns of birth, death, and renewal. In this model, the Big Bang is not a one-time event but perhaps part of an undying cycle where universes form independently and then rejuvenate in another cycle. This theory suggests that our universe could have been restored from the remnants of a previous universe. The process of compression and expansion in a cyclic pattern would mean that there was never a true beginning, but rather an eternal series of emerging universes renewing themselves again and again. Cyclic cosmology raises significant questions, never a better time than right now, as it suggests that time itself could repeat rather than continue. If this hypothesis is right, it could mean that what existed before the Big Bang was essentially another form of the universe, one that fell exclusively to give birth to our current universe. For scientists, this theory offers a rich solution to the question of extreme origins, suggesting that there is no clear beginning. The universe has always existed in some form, transcending our concepts of time and existence. Gravitational waves are another intriguing thought that could shed light on what existed before the Big Bang. These waves, discovered in 2015, are ripples in spacetime caused by incredibly massive objects like black holes or colliding neutron stars. These waves can travel great distances, carrying information about the events that created them. Could gravitational waves provide insight into the creation of the universe? A few physicists suggest that gravitational waves from the time before the Big Bang might offer clues about the state of the universe before inflation began. It's possible that the early universe left traces that could help us understand whether the Big Bang was truly the beginning or whether there were cosmic events before that we don't yet appreciate. These waves could be remnants left by events beyond our usual understanding. Their presence might also imply a greater structure beyond the one we are familiar with. These faint signals could open insights that change our perspective, just as we uncovered the Big Bang's origin. Consider the potential for them to exhibit faint traces of a past universe or an event that occurred prior to the Big Bang. As researchers continue to explore the deep reaches of space, the question remains, what existed before the Big Bang? With current hypotheses highlighting quantum mechanics, multiverse, and cosmic expansion, it seems we are closer than ever to unraveling the deep secrets of the universe's beginnings. While the complete answer remains elusive, our understanding of what existed before the Big Bang continues to evolve with each discovery. As we explore these hypotheses, we can also consider how they may fit together to reveal the larger picture, the true essence of existence itself. But we are left with the mystery until then, driving science forward and wandering into obscure places far beyond what we have yet known. We continue to delve into the secrets of what existed before the Big Bang. Clearly, our understanding of the universe is constantly evolving. One critical area of investigation involves the relationship between existence itself and time as we experience it, as if no time had passed in the way we understand it before the Big Bang. Some theories propose that time as a concept started with the Big Bang, making it impossible to trace what came before. This thought challenges our fundamental perception of existence, suggesting that the question of before may not actually be relevant when it comes to the universe's origins. Moreover, later advances in the study of quantum mechanics have sparked new ideas about the nature of reality. One particularly captivating concept is the possibility of a quantum vacuum, a state where, even in the absence of matter, the universe isn't genuinely empty. Rather, it is filled with fluctuating energy fields that can give rise to particles and forces. These quantum fluctuations could have played a crucial role in the formation of the universe, as they might have provided the essential conditions for the Big Bang to occur. This raises the question of whether the universe might have emerged from a quantum change or, alternatively, if it was somehow triggered by these fluctuations. Another intriguing aspect of pre-Big Bang theory revolves around the idea of cosmic recycling. In cyclic cosmology, the universe is filled with innumerable series of expansions and contractions. After each Big Bang, the universe would eventually shrink back into a singularity before expanding again. This cyclical process could truly mean that the current state of the universe is just the latest iteration in an eternal series of cosmic births and deaths. Some scholars propose that each cycle could lead to slightly different outcomes, with the current configuration of the universe being shaped by the conditions of the previous cycle. This idea challenges the notion of a definite beginning, suggesting instead that the universe is in a constant state of renewal. The possibility of additional dimensions also adds another layer of complexity to how we might interpret what preceded the Big Bang. String theory, for instance, hints at the existence of extra dimensions beyond the familiar 3 dimensions of space and 1 dimension of time. These additional dimensions could provide an entirely new framework for understanding the universe's origins. Expanding on these ideas, one could speculate that the laws of physics themselves may have evolved over time, shaped by the transitions between cosmic cycles. If the universe undergoes repeated cycles of birth and collapse, could the fundamental constants of nature, such as the strength of gravity, the speed of light, or the properties of elementary particles, be slightly different in each iteration? This concept aligns with the idea of a multiverse, where each universe within the cycle could have its own distinct physical laws. If so, then our current universe may simply be one version among an infinite number of possibilities, each shaped by the remnants of what came before. The role of quantum mechanics in the pre-Big Bang universe. Quantum mechanics introduces another layer of mystery to what may have existed before the Big Bang. One possibility is that the universe originated from a quantum fluctuation, an event in which tiny, probabilistic changes in energy led to the sudden emergence of space and time. In this view, the universe could have formed from a quantum vacuum, a state where energy fields constantly shift and create particles momentarily before disappearing again. If the Big Bang was triggered by one of these fluctuations, then it may not have been the first time such an event occurred. The universe could be part of a vast, ever-changing quantum landscape, where entire universes form and dissolve beyond our observational reach. Some physicists suggest that the quantum vacuum could be eternal, meaning that space and time may have always existed in some form, though not in a way we can yet comprehend. This would challenge the notion that there was ever a before in the conventional sense and instead suggest that time itself is a property that emerged with our universe. The mystery of time before the Big Bang. If time did not exist before the Big Bang, as some theories propose, then our very question of what came before might be flawed. Time, as we understand it, may have begun at the Big Bang, meaning that the idea of before simply doesn't apply. However, alternative theories suggest that time may be cyclical or multidimensional. If time exists in more than one dimension, it could function in ways beyond our usual understanding, potentially looping back on itself or existing as a static, unchanging field that only appears linear from our perspective. One idea that emerges from this possibility is that our perception of time as a one-way progression may be a limitation of human understanding. If time were more fluid or complex than we perceive, then the universe's origin might not be a singular event but rather a transition between different states of existence. Could black holes hold the answer? Another intriguing theory involves black holes. Some physicists propose that the Big Bang may have been the result of a massive collapse within a higher dimensional space, much like the way a black hole forms within our own universe. In this scenario, what we perceive as the Big Bang could actually be the event horizon of a much larger cosmic structure. If this were true, then our universe could be a kind of baby universe, formed from the collapse of matter in another, larger cosmos. This idea is linked to the concept of a multiverse, where black holes could serve as gateways between different universes, allowing matter and energy to transition from one reality to another. The search for evidence. While many of these ideas remain theoretical, ongoing research into cosmic background radiation, gravitational waves, and quantum physics may provide clues that help us understand what existed before the Big Bang. Future discoveries could reveal whether our universe is part of a larger multiverse, whether time is cyclical, or whether the laws of physics themselves are evolving across cosmic cycles. As we continue to explore the nature of existence, one thing remains clear: the question of what came before the Big Bang is one of the most profound mysteries in science. Whether the answer lies in quantum mechanics, cosmic recycling, or a yet undiscovered theory, the search for truth pushes the boundaries of human understanding and challenges our deepest assumptions about reality.